How are y'all doing today? Hope everyone's doing alright. So, I hope everyone felt pretty good about the test. Hopefully by probably not Wednesday, but hopefully by Friday I'll have it graded. Um, we'll see how that goes. But anyway, um, yeah. I think today we'll just start slow and work on section 4.3, and it may not take the full time, and that's okay. So, but yeah. I can't go over it quite yet because one person still needs to take it after they emailed me about some technical difficulties yesterday. Um, but on Wednesday, if you have specific questions, we can go over anything. And I still intend to make videos. This includes test one, where I go over the answers for each of the problems and just show how everything's worked. And hopefully I'll be able to get to that soon. So. Okay. So section 4.3, chapter 4, we're really only covering two sections in chapter 4. This is 4.3 and 4.4. We're still on quadratic functions, but this is kind of the last go at it before we move on to polynomials and rational functions. Now, okay, Gabriel, good luck with that. Definitely a test you want to pass. I guess it depends on what the context of passing means. Anyway, quadratic functions and their properties. Okay. So we feel like we've done quite a bit with quadratic equations, and we have, and quadratic functions. We've done some basic graphing in section 3.5 using the transformations, but now we want to make a larger connection between the coordinates or key points on the graph of a function, and how does that affect where the graph is located. Anyway, so our basic form is f of x is ax squared plus bx plus c, as we're familiar with. Okay. But we also have what's called a standard form, where we redefine f of x as being equal to a times x minus h in parentheses squared plus k. Now, this is basically what we were looking at in the 3.5 lecture, because now we can treat h and k as horizontal and vertical shifts, and a as stretching or compression. If it's negative, it'll be a reflection also. But in the standard form, h comma k is the vertex. Okay. So when we talk about the vertex of a parabola, that would be this point right here. Now the vertex is either the highest or lowest point on the graph, depending on which direction the parabola is opening, up or down. Okay. Notice that this is x minus h, yet we used a positive h in the coordinate. It's connected to the same reason why x minus 3 is a horizontal shift of 3 to the right rather than to the left. It's the same property being exhibited there. Okay. So, the way that we can go from basic form to standard form is h is actually equal to negative b over 2 times a, and then to find k, we just take that h value we calculated and plug it back into the function and find f of h. Okay. So we might say, for example, we want to write the function in standard form. And we're given f of x is equal to x squared plus 6x plus 13. Okay. So h is negative b over 2a. So our b value in this case is 6. So negative of that would be negative 6. A is 1. So we end up with negative 6 divided by 2. And that gives us a value of h equals negative 3. Now, we take that negative 3 that we got for h and we plug it back into the function for x. X is negative 3, so we do negative 3 squared plus 6 times negative 3 plus 13. So we get k is 9 minus 18 plus 13. 9 minus 18 is negative 9. Negative 9 plus 13 will give us a positive 4. So we get a value of k equals 4. And so putting that in the standard form, f of x is equal to, now a in this case is just 1. So whatever a is in the original function, we'll have the same number outside in the standard form. Okay? But the only changes we make is that we write this as x minus h squared plus k. A stays the same though. Now, because it's 1, we don't really have to write a 1 in front, because it is assumed to be a 1 already. Now, we said x minus h in our formula, so minus negative 3 becomes x plus 3 squared, and then k is 4. Okay. So that would be our function in standard form. And the vertex is located now at negative 3 comma 4, which we can either look at as being h and k, or remember from the function it's the opposite of this number and then this number. Okay. Okay. So that's how we can write in a standard form. Now, going off of what we just did in the end of last chapter, we know that if we wanted to sketch this graph, we would go 3 places to the right and 4 up, and then draw our parabola there. It's the same principle as using the vertex. The vertex actually is 3 left. I said it wrong. Sorry. 3 places to the left, go up 4. That's our vertex, and then we draw our parabola from there. So this particular function would look something like this. Okay. So it's another way that we could potentially sketch this graph is by putting it into standard form and then using our transformations. Now, it turns out there are other properties about the quadratic functions that are helpful when it comes time to graph. Okay, so if we have f of x equals ax squared plus bx plus c, if a is greater than 0, the parabola opens up. And if a is less than 0, then the parabola opens down. Oh, sure thing, Madison. Let me finish writing this. Okay, So we said that the basic form was ax squared plus bx plus c, and we established that the standard form was a times x minus h squared plus k. We said the coordinate h comma k is the vertex of the parabola, which is either the lowest point or the highest point, depending on which way it's facing. And the way that we calculate these is that we find h is negative b over 2 times a, and then whatever number we get here, we plug it back into the function, and that helps us find k. So h and k are a coordinate on the graph specifically, but it will be this vertex point. Now, here our instructions are to write the function in standard form. We start off with f of x is x squared plus 6x plus 13. We calculated negative b over 2a, so negative 6 over 2 times 1. Excuse me. And we end up with negative 3. We take our negative 3, plug it back in, we evaluate that into the function, and we get 4. So that means our vertex is negative 3 comma 4, and the way that we set up our function is x plus 3 parentheses squared plus the 4. This one's always opposite of what's here, from the vertex to the function. All right. So, we said here that there are some other aspects that are helpful in graphing the function. One is that the sign of the value of a tells us if it opens up or if it opens down. And that actually coincides with what we learned from section 3.5, where if it was multiplied by a negative, it would reflect the graph downward. That same principle is seen here. Because if it's multiplied by a negative, we'll have a negative a value, which will result in a parabola that opens down. The other thing is that we can also use the intercepts to help sketch the graph. And this will give us a more accurate graph than if we're just drawing it based on where the vertex is. So f of x equals 0 gives the x-intercepts, and f of 0 gives the y-intercept. Okay, so the next thing that we want to do, and the book goes into way more on this stuff, way more into these things than I feel is really necessary, because they're going to ask us increasing and decreasing, where the function is positive, where the function is negative. I'm not going to have you do all that. I just want you to be able to just use these things that we're talking about here to help sketch the graph. So we have the whether it opens up or down, we have the vertex that we already talked about, and then also the intercepts. Those are the main things that we should focus on. Okay. So we also have the vertex h comma k, where we said h is negative b over 2a, and k is f of h. So we have that as well. And generally, we'll find the vertex before we find the intercepts. That's the typical course of action there. Now, not all parabolas will have x-intercepts. It turns out the question we just worked, this graph does not cross the x-axis at all. We can find a y-intercept. Every graph will have one y-intercept, but it may be that it doesn't have any x-intercepts. It really just depends on the function there. We can guarantee a vertex, we can guarantee a y-intercept, but not necessarily x-intercepts. So just keep in mind that's not something we may always have. It may be that we, when we go to find the x-intercepts and we set the function equal to 0, it may not have any real solutions. It may have imaginary solutions, which is what happens when the graph is actually above the x-axis and going upwards from there. So if we were to solve this function that we were looking at before, we would find that our setting that equal to 0 results in imaginary or complex solutions, meaning it doesn't actually cross this x-axis. Okay. So for example, let's look at excuse me, f of x is negative 2x squared plus 8x let's say plus 6. Yeah, that's a nice graph. Alright, first of all, does this function open up or down? Down, and again, the way that we can tell that is with the first term being negative. We know it opens down. Let's do the vertex second. And for the vertex, we said h is equal to negative b over 2a. b is 8, so we get negative 8. A is negative 2, so 2 times negative 2 will give us a negative 4. And then dividing those, negative 8 divided by negative 4, that gives us a value of positive 2, so h would equal 2. So to find k, we would take h equals 2 and plug it back into the function. So now we want f of 2 Okay, so negative 2 times 2 squared plus 8 times 2 plus 6. 2 squared is 4, negative 2 times 4, so negative 8 plus 16 plus 6. So k would equal 14. So 2 comma 14 is the vertex. All right. Next, we'll get the intercepts. For x, we said f of x equals 0. So in this case, we have negative 2x squared plus 8x plus 6 equal to 0. Now, a couple of things about that equation as far as when we solve it. One, it starts with a negative and also has a negative 2 specifically. That means we don't really want to factor it like it is. We could use the quadratic formula, but we notice that every number here is a multiple of 2. What we could do instead is factor out the negative 2 Uh-oh. I may have made a miscalculation. Oh well. We'll run with it. The miscalculation being that our their solutions here are not a real number. I mean, it's a real number. It's not a rational number. That would be my error. I think I meant to make that a minus 5, so I should have made it a plus 10 in the original problem. Y-intercept would be 0, 6, absolutely. Although I wanted this to be factorable. I guess I could have made it plus 3, that would have worked. Debating just redoing the entire problem. Let's do that. I don't want to have to go back and change that. Let me just let's skip the part where we have a 2 in there, and this will make it easier for me to create. Well, it wasn't exactly successful, that last one, but yes. Hello, Amanda. How are you doing? Yeah, I wanted to make sure we have one that opens down, and good call on that, August. Yeah, we know it opens down. doing okay. I'm really tired this morning, but this is my own fault, so I understand that. Not that I ever changed my behavior. So. It's quarantine life. You know how it is. Alright, a vertex, in this case... vertex would be negative, or sorry, let me write the whole thing. H equals negative b over 2a. So negative 4 over 2 times negative 1 would be negative 4 over negative 2. So we keep h as 2. And then our k value, we take that 2 that we just got and plug it back into the function. So negative 2 squared plus 4 times 2 plus 5. So what is k going to equal? It's actually not 17, but that's exactly what I'm challenging everyone on here. Nine. The tricky part is right here. And honestly, this is what trips up all of my classes, for years and years now. And this is why I like to ask this question, or something similar to it. Whenever we plug in a positive number here, and we have that negative x squared, we end up with a negative 2 squared. And what makes it difficult is the order of operations that has to take place here. Because most people look at that and say, we're squaring in negative 2, so it becomes positive 4. But the question is, are we actually squaring in negative 2? So, if we're squaring in negative 2, we get positive 4, and then 8 and 5, that makes 17. But what we're actually squaring is a positive 2. So positive 2 is being squared. We do the square first, and then the negative happens after that. Exponent happens before subtraction. So we do a 2 squared, which is 4, and then it becomes negative. So it's a negative 4 plus 8 plus 5. Well, you did get the correct answer. May have been 2 mistakes. It turns out 2 consecutive mistakes sometimes lead you to the right answer. But we want to make sure we get the right answer for the right reason. Not for making 2 consecutive errors, even numbers of errors. Yeah, only in math can you make an even number of errors and still come out correct. But you have to be lucky in some respect. So, anyway. Yeah, negative 4 plus 8 plus 5. So it does come out to be 9. So the vertex is 2 comma 9, correct. Okay, now the intercepts. Honestly, the y-intercept is the easiest. What is the y-intercept here? Remember, we plug in f of 0 to get the y-intercept. Five. Yeah, because if we plug in 0 for x, that zeroes out these first two terms, and it just leaves us with 5. So we can always look at the constant in the function as the y-intercept. X-intercept is a little bit more involved because it does usually involve factoring or solving a quadratic equation. The fact that we plugged in 0 for x and got a 5 for y, that sets up our coordinate. Is that what you're asking about, Amanda? Yeah, whenever we have a y-intercept, we always plug in x equals 0. We got a value of y equals 5, so 0, comma 5. Yeah, you could do it in either form. It doesn't have to be original form, although we tend to, whenever we're finding intercepts, it actually works better in original or general form than standard form. So you'll notice that we found the vertex and everything. We didn't write it in standard form this time. Standard form is really just a way of showing that we can connect the transformations to the other aspects of the function. In general, though, we prefer to leave it as it is and then find all these things based on that. Okay. Now, because we have a negative x squared here, I'm just going to multiply everything by negative 1, and that'll make it everything. That'll be a positive. And we want to make sure x squared is positive when we factor. That way, our method of factoring actually works. So how do we factor x squared minus 4x minus 5? Not so much, no. I mean, it's useful, but it turns out when you get to calculus, there's easier ways of managing that. So. X minus 5 and x plus 1, that's correct. Okay. And so we get x equals 5 and x equals -1. And so if we create coordinates to go along with those, it'll be 5, 0 and -1, 0. This time, because we plugged in 0 for y, and we found x equals 5, that means x is 5, y is 0, x is -1, y is 0. Okay. And you'll notice that by this point we have 4 different coordinates that we found on the graph of f of x. We have our vertex, which in this case is the top point on the graph since it opens down. 0, 5 is the y-intercept, 5, 0, and -1, 0, these are the x-intercepts. So if we wanted to put this together, let's see, this is all happening towards the right. Okay. So we have 2, 9 is the vertex. 0, 5 is the y-intercept. 5, 0 is one x-intercept, and then -1, 0 is the other. And so connecting these from the vertex, will allow us to sketch the parabola. And now this is a much more accurate sketch than we produced in 3.5 because now we have all these different points that we found that are aiding us in the process. Alright. Any questions on this one? Now that we have the graph, we also can find the domain and range. What is the domain, first of all? All real numbers, yes. Because we have the arrows on the left and the right hand side, so it's going to continue infinitely to the left and to the right. And the range is 9, -infinity. Very close. You have the right numbers, so the only thing I would say on that range is make sure you put the low number first. So I just switched that around. So -infinity to 9. It seems nitpicky, but we always go low to high whenever we express domain and range. So the lowest number on the graph vertically is -infinity, the highest is 9, and so we make sure we put a bracket on 9 because that's included in the graph. It's just a standard ordering. whenever we do interval notation. I mean, we could also, if we wanted to, just say the range is y is less than or equal to 9, and that is equally valid. But yeah. Okay. So this problem had a little bit of everything. Again, we determined that because it has a negative in front, it opens down. A is -1, less than 0. Vertex, we took h was negative b over 2a. Calculated that out to be a 2. And we took that 2 and plug it back into the function to find k. F of 2 turns out to be 9, so k is 9, and that means our vertex is 2, 9. Then we found the intercepts. Y-intercept is always f of 0, which is 5 in this case. And then f of x equals 0, set to find x, we set negative x squared plus 4x plus 5 equal to 0. We multiplied by a -1 to make it a positive x squared, because multiplying by a number doesn't change the zeros, it changes the signs to help us better find those zeros. And so we got our factorization, x minus 5x plus 1, which gives us x equals 5 and x equals -1, and so we set that up as ordered pairs, just like we did here. And so taking our 4 ordered pairs, we're able to sketch a graph of the function. And then based on the graph, we were able to find the domain and range. As I said, the book is going to ask you to also determine where the function is increasing and decreasing and where it's positive and negative. We're not going to go into that much detail. So whenever I assign those problems, I will be sure to leave out that part of the question. The other thing that we didn't find, although we have all the information for already, is what's called the axis of symmetry. Now, the axis of symmetry is kind of not imaginary, it's a line that goes through the middle of the parabola, basically cuts the parabola in half so that the left half is symmetric to the right half. Okay, and so it actually goes right through that vertex. And we would actually say it's at x equals 2 is the equation on that line. And so we're not going to worry about that. In finding the vertex, we already found the axis of symmetry. That's what the h value specifically represents. But I'm not going to worry about that, because in general, I've been skipping the symmetry aspects of this course, which is what I always do. It's not as important as this book makes it out to be. All right. Any questions on that? All right. Let's see. homework. On page 309. Look at 23, 25. What else? We can do 43. '45, 47, and I don't like any of these other ones. We'll go ahead and try 57, but just for today, you know. And we honestly, we don't go an hour 30, we go an hour 20. So, all right. So I think we'll leave it at that for today. On Wednesday, we'll wrap up section 3 and go over section 4 as well. Okay. So you'll have a good rest of your day, and we'll do this again on Wednesday. 57 is looks like this. That's the best way to express what's going on there. It's not going to have a whole number as your H or as your K. So that's the caveat on 57. We'll be working with fractions. You could potentially use decimals instead of fractions. So I think they'll be worth pursuing. But the x-intercepts will also be a little bit challenging to find because of the way the function is set up. So, yep, y'all take care. I'll see you next time.